Welcome. Today we're diving into the world of FinFET, a groundbreaking technology that has transformed the semiconductor industry. As devices get smaller and more powerful, traditional transistors face limitations. FinFET, short for Field Effect Transistor, offers a solution by changing the way transistors are built and function. In this video, we'll explore what makes FinFET unique, why it matters, and how it's shaping the future of electronics. Let's start by understanding the basics of transistor technology and why innovation was needed in the first place. As technology advanced, the demand for faster, smaller, and more energy-efficient devices grew rapidly. Traditional planar transistors, which have been the backbone of electronics for decades, began to hit physical and performance limits. Issues like leakage current and short-channel effects became more pronounced as transistors shrank. This created a pressing need for a new approach that could keep up with Moore's law and continue the trend of miniaturization without sacrificing performance or efficiency. FinFET stands for Field Effect Transistor. Unlike traditional flat transistors, FinFETs use a thin, fin-like structure that rises above the substrate. This 3D design allows for better control of the current flow, reducing leakage and improving performance. The gate wraps around the fin, which means more surface area for the gate to control the channel. This innovation is key to enabling smaller, faster, and more energy-efficient chips that power modern electronics. Main difference between FinFET and traditional planar transistors lies in their structure. Planar transistors are flat with the gate sitting on top of the channel. In contrast, FinFETs have a vertical fin that the gate wraps around on three sides. This 3D structure gives the gate much better control over the channel, which helps reduce leakage and allows for smaller transistor sizes. As a result, FinFETs can operate at lower voltages and higher speed. FinFET consists of a thin silicon fin that forms the channel, with the gate electrode wrapping around it. The source and drain are located at either end of the fin. This unique structure increases the contact area between the gate and the channel, which enhances the transistor's ability to switch on and off efficiently. The fin's height and width can be adjusted to optimize performance for different applications, making FinFETs highly versatile. FinFET technology brings several key advantages over traditional planar transistors. First, it significantly reduces leakage current, which means less wasted power in cooler chips. Second, the improved gate control allows for faster switching speeds, enabling higher performance. Third, FinFETs can be made smaller, supporting the ongoing trend of device miniaturization. These benefits make FinFETs ideal for modern processors and mobile devices. One of the standout features of FinFETs is their ability to operate at lower voltages without sacrificing performance. This leads to significant reductions in power consumption, which is crucial for battery-powered devices like smartphones and laptops. Lower power usage also means less heat is generated, improving device reliability and user comfort. This efficiency is a major reason why FinFETs are now standard in leading-edge chips. FinFETs enable higher performance by allowing transistors to switch on and off more quickly. The improved gate control provided by the 3D fin structure means that signals can travel faster and with greater precision. This translates into faster processors and more responsive devices, which is especially important for applications like gaming, artificial intelligence, and high-speed computing. Today, FinFET technology is used in the most advanced processors from companies like Intel, AMD, and Apple. These chips power everything from smartphones to servers, delivering the performance and efficiency needed for demanding applications. The adoption of FinFET has enabled manufacturers to continue shrinking transistor sizes, packing more power into smaller chips, and keeping up with the rapid pace of technological innovation. While FinFETs offer many benefits, they also introduce new manufacturing challenges. Building the tiny, precise fins requires advanced fabrication techniques and equipment. The process is more complex than traditional planar transistors, which can increase costs and require new expertise. Despite these hurdles, the advantages of FinFETs have made them the technology of choice for leading-edge chips. FinFETs have enabled the continued scaling down of transistor sizes, following Moore's law. As chipmakers push towards smaller nodes such as 7nm and 5nm, FinFETs provide the control and efficiency needed to maintain performance. This scaling is essential for creating more powerful and compact devices, from smartphones to data centers, and keeps the industry moving forward. Moore's law predicts that the number of transistors on a chip will double every 2 years, leading to exponential growth in computing power. FinFET technology has played a crucial role in keeping this trend alive, allowing chipmakers to pack more transistors into the same space without running into the limitations of planar designs. This has kept the momentum of innovation going strong. Mobile devices like smartphones and tablets benefit greatly from FinFET technology. The reduced power consumption and increased performance mean longer battery life and smoother user experiences. As mobile applications become more demanding, FinFETs ensure that devices can keep up without overheating or draining the battery too quickly. Data centers require massive computing power and energy efficiency. FinFET-based processors help meet these needs by delivering high performance while keeping power consumption in check. This allows data centers to handle more workloads, support cloud computing, and reduce operational costs, all while maintaining reliability and speed. Artificial intelligence applications demand fast, efficient processing. FinFET technology provides the speed and power efficiency needed for AI workloads, from machine learning to neural networks. This enables smarter devices, faster data analysis, and breakthroughs in fields like healthcare, finance, and autonomous vehicles. From smart TVs to gaming consoles, FinFET technology is at the heart of many consumer electronics. The improved performance and energy efficiency translate into better user experiences, with faster load times, smoother graphics, and longer device lifespans. As electronics continue to evolve, FinFETs will remain a key enabler of innovation. Internet of Things, IoT connects billions of devices from smart home gadgets to industrial sensors. FinFET technology enables these devices to be smaller, more energy efficient, and more powerful. This is essential for IoT, where devices often operate on limited power and need to process data quickly and reliably. Modern vehicles rely on advanced electronics for everything from engine control to infotainment systems. FinFET-based chips provide the performance and reliability needed for these applications, supporting features like autonomous driving, advanced safety systems, and in-car entertainment. As cars become smarter, FinFET technology will play an even bigger role. Healthcare technology, from wearable fitness trackers to advanced diagnostic equipment, benefits from FinFET's efficiency and performance. These devices require reliable, low-power chips to monitor health data, process information, and communicate with other systems. FinFETs help make healthcare devices more accurate, portable, and user-friendly. Security is a top concern in modern electronics. FinFET technology supports advanced encryption and secure processing, making it harder for attackers to compromise devices. The improved performance also allows for real-time security features, such as biometric authentication and secure data storage, which are essential in today's connected world. Cloud computing relies on powerful, efficient processors to deliver services to millions of users. FinFET-based chips help data centers run more efficiently, supporting everything from streaming video to online collaboration tools. This technology ensures that cloud services remain fast, reliable, and accessible to users around the globe. The rollout of 5G networks is transforming how we connect and communicate. FinFET technology enables the high-speed, low-latency chips needed for 5G infrastructure and devices. This supports faster downloads, smoother streaming, and new applications like augmented reality and smart cities. While quantum computing is still in its early stages, FinFET technology is influencing the development of control and interface circuits for quantum processors. The precision and efficiency of FinFETs make them suitable for supporting the unique requirements of quantum systems, paving the way for future breakthroughs. Edge computing brings data processing closer to where it's needed, reducing latency and improving efficiency. FinFET-based chips are ideal for edge devices, offering the performance and low power consumption required for real-time processing in applications like smart cameras, industrial automation, and autonomous vehicles. Wearable devices, such as smartwatches and fitness trackers, rely on compact, energy-efficient chips. FinFET technology enables these devices to run longer on a single charge while providing the performance needed for health tracking, notifications, and connectivity. This makes wearables more practical and appealing to users. Smart home devices, from voice assistants to security cameras, benefit from FinFET's efficiency and performance. These chips enable always-on features, quick response times, and secure operation, making smart homes more convenient and reliable for everyday use. Gaming consoles and PCs demand high performance and efficient cooling. FinFET-based processors deliver the speed and power needed for immersive graphics and smooth gameplay, while keeping energy consumption and heat generation in check. This results in better gaming experiences and longer hardware lifespans. Robots, whether in factories or homes, require reliable, high-performance chips. FinFET technology provides the processing power and efficiency needed for robotics applications, enabling smarter automation, faster response times, and more advanced features. Industrial automation relies on robust, efficient electronics to control machinery and processes. FinFET-based chips offer the reliability and performance needed for real-time control, predictive maintenance, and data analysis in industrial settings, driving productivity and innovation. Energy efficiency is a top priority in modern electronics. FinFET technology helps reduce overall power consumption, making devices more environmentally friendly and cost-effective to operate. This is especially important as the number of connected devices continues to grow worldwide. Researchers are constantly exploring new ways to improve FinFET technology, from materials to manufacturing processes. These efforts aim to push the boundaries of performance, efficiency, and scalability, ensuring that FinFETs remain at the forefront of semiconductor innovation. Educational institutions use FinFET-based chips in research and teaching, helping students and scientists understand the latest advances in semiconductor technology. This prepares the next generation of engineers and innovators to tackle future challenges in electronics. Sustainability is becoming increasingly important in technology. FinFETs contribute by enabling more energy-efficient devices, reducing electronic waste, and supporting green initiatives. As the world moves towards more sustainable practices, FinFET technology will play a key role in making electronics more environmentally friendly. The future of FinFET technology is bright, with ongoing research into new materials, architectures, and manufacturing techniques. Innovations like gate-all-around GAA, transistors, and nanosheet designs are being explored as the next step beyond FinFET, promising even greater performance and efficiency. FinFET technology has had a global impact, enabling advances in computing, communication, healthcare, and more. By making electronics faster, smaller, and more efficient, FinFETs have helped bridge the digital divide and bring new opportunities to people around the world. The adoption of FinFET technology has driven economic growth by enabling new products, services, and industries. From startups to tech giants, companies leverage FinFETs to create innovative solutions that fuel job creation and economic development worldwide. The widespread use of FinFETs has influenced the global semiconductor supply chain. Manufacturers, suppliers, and designers must collaborate closely to meet the demands of advanced chip production, ensuring a steady supply of high-quality components for the world's electronics. Semiconductor technology is critical to national security. FinFET-based chips power defense systems, secure communications, and critical infrastructure. Ensuring the reliability and security of these chips is a top priority for governments and industry leaders worldwide. Open-source hardware projects are increasingly using FinFET-based chips to develop innovative solutions. This democratizes access to advanced technology, allowing more people to experiment, learn, and create new devices that benefit society. FinFET technology helps make electronics more accessible by enabling affordable, high-performance devices. This supports digital inclusion, allowing more people to participate in the digital economy and access information, education, and services. Custom chips or application-specific integrated circuits ASICs often use FinFET technology to achieve the best performance and efficiency for specialized tasks. This is important in fields like cryptocurrency mining, scientific research, and telecommunications, where tailored solutions are needed. Chip designers leverage FinFET technology to create innovative architectures that push the boundaries of what's possible. The flexibility of FinFETs allows for creative solutions to complex challenges, enabling the next generation of electronics. Testing FinFET-based chips is crucial to ensure quality and reliability. Advanced testing methods are used to detect defects, measure performance, and guarantee that chips meet the high standards required for modern electronics. Chip packaging is an important step in bringing FinFET-based devices to market. Advanced packaging techniques help protect the delicate fins, improve heat dissipation, and enable higher levels of integration, supporting the development of powerful and compact devices. As we look to the future, FinFET technology will continue to evolve, driving new innovations in electronics. With ongoing research and development, we can expect even more efficient, powerful, and versatile chips that will shape the next generation of devices. FinFETs have already changed the world of semiconductors, and their impact will only grow in the years ahead.